So given is the net force versus time graph, and the mass of the object is 3 kilograms. So by Newton's second law, net force equals mass times acceleration. So you take the net force values and you divide it by 3 kilograms, getting your accelerations for each time period. Then you take, because you're dividing by a constant, the shape of the graph will be the same as the force graph. So you take these constants and you graph them for the given time periods, and this is the acceleration graph. So between times 0 and 2, acceleration is 3 meters per second, so you would graph a horizontal line of 3. Then from time 2 to 3, the acceleration is negative 2 meters per second squared, so you graph a horizontal line of negative 2. From 3 to 4, the acceleration is 0, so the line is at 0. And then for time 4 to 5 seconds, the acceleration is 1 meter per second squared, so you graph a horizontal line of 1 meter per second.
So to find the velocity graph, you take the velocity as a function of time and set it equal to the initial velocity plus the integral of the acceleration, and you plug in 5 seconds, so at 5 seconds the velocity is 2 meters per second, and then after solving the equation you get the initial velocity is negative 3 meters per second, and then that's going to be our starting point. And then we figure out that from 0 to 2 seconds the velocity is increasing at 3 meters per second squared based off of our acceleration calculations. So it's going to increase a total of 6 meters per second over 2 seconds. So over 2 seconds we go up 6 meters per second, and we're at 3 meters per second. And then from 2 to 3 seconds we are decelerating, so at 2 meters per second squared. So we're going to decrease 2 meters per second over the 1 second period. And then from 3 to 4 seconds the velocity is constant because there's no more forces acting on the object. So it's just a straight line across. And then from 4 to 5 seconds the velocity is increasing at 1 meter per second. So it increases a total of 1 meter per second, and the final velocity is 2 meters per second.
Okay, so now we're going to derive the position versus time graph from the velocity versus time graph. We're given the initial condition that at 5 seconds the x position is positive 5 meters, which is this point. And since position is the integral of velocity, we are going to look at the displacement of x, which is the area under the velocity graph. So we're going to be working backwards from 5 seconds to 0 seconds in order to get the graph, since our initial condition was at 5 seconds. So the area under the velocity graph from 4 to 5 seconds is 3/2. So we know that working backwards at 4 seconds our position will be 3.5, since 5 minus 3/2 is 3.5. And since in the velocity graph the slope is increasing from 4 to 5, the concavity of our position graph will be positive. So the slope will be smaller here than it will be here. So that's how we get this curve. And then at 4 seconds we're at 3.5 meters to the right. And then we're going to continue to work backwards, and we're going to look at the displacement from 3 to 4, which is 1 meter. So therefore we know that the position at 3 seconds is 1 meter less than the position at 4 seconds. So 3.5 minus 1 is 2.5. And since the slope of the velocity graph is constant at this point, or since the slope of the velocity graph is 0, we know that this slope will be constant, so it's just a straight line from 2.5 to 3.5. And then so then we'll move on from the line segment 2 to 3, and going back to the velocity graph, the displacement from 2 to 3, or the area under this curve, is 2 meters. So we know that the position at 2 seconds will be 2 meters less than the position at 3 seconds. 2.5 minus 2 is a half. And then for this one, the slope of the velocity graph is decreasing. So we know that the concavity from 2 to 3 will be negative, or the slope is greatest here, and then it decreases 2, 3. And then from the time segment 1 to 2 seconds, we'll go back to our velocity graph, and we'll see that the displacement is 3/2. So we'll subtract 3/2 from a half, and we'll get down to -1. And once again, on the velocity graph, the slope is positive. So the concavity of this graph will also be positive, and we'll get this curve. And then finally, from 0 to 1, the displacement will be -3/2. So we know that we'll have to add 3/2 to this value. So -1 plus 3/2 is 1/2. And the slope of this is positive. So we know that this concavity will be positive. So that's how we get this curve. And that's your position versus time graph.